So next up, we have something on evolving in the Gaia-X transport protocol and different connectors. We have moving into the academic realm. So I'd like to welcome Andres and Carlos, both from the University in Madrid, who will, shed some light on that topic. Please join me on stage. I got 2 microphones. I got one. This is number 1. And so you don't have to switch. This is number 2.
Okay, thank you so much. For us, it's a pleasure to be here. It's the second time that we are here in the Gaia-X hackathon and conference. So we are from academia. So right now, the focus of this presentation is trying to show you more or less the research part that we have been developed in some of projects that we have. More or less to show you the profile that we have. Many of you know Joaquin. Okay, Joaquin can be here because he has some problems with the schedule, but Joaquin is a full professor of the Politécnica University of Madrid. And then we have Carlos here, that is a senior researcher from our group, and I am an assistant professor from the same university. More or less, one thing that we want to show you is the activities in terms of research that we are doing regarding our research group. We have been developing some things about data spaces, but also focus in another research line like big data, cloud computing, also LLMs, AI, and many other research topics that we can collaborate with many other universities or many other entities. So we are from the School of Telecommunications, so we have many experience about protocols, about many topics of integration in terms of transport, also in data sharing, and many other things. So what we want to show you today, or present you today, we have been working in some project called Eunomia. Eunomia, you know, when you are trying to get some project, the first big decision is trying to define a name. In this case, this name is Eunomia because we have some inspiration of the ancient Greek. In this case, we define Eunomia because he was the goddess of laws. And this project is more regarding governance, laws, access control, and many other things regarding data spaces. Our mission is trying to work more or less in this type of topics. As you can see, we have a very long list of things that we need to develop in this project, but this presentation is summarized in 3 main topics. In this case, this project is supported by the cybersecurity, the Spanish Cybersecurity Institute, and we are going to present many things regarding to how we can propose new ways to face the gaps that are in transport protocols, also how we can integrate ODRL and the policy engine of ODRL with a new approach of access control based on a recent architecture that is zero trust, trying to evolve more or less the XACML architecture that we have. Also, we trying to provide more integrations with all the connectors that we have in the data space ecosystem, and many other proposals that we have right now regarding or related to this project. Okay, this presentation, the content of this presentation has 3 main topics. First, we have the integration at the level of transfer protocols inside of all the connectors. We are going to present you more or less what is the approach that we need to address in this case for facing some gaps that we need to consider when we want to share data, but at transport level. The other topic is the integration of most trust anchors. In this case, we have seen the problematic that that we identify that we need a test bed for trying to do the first step working with data spaces, okay? And so we are trying to do some things and provide some infrastructure to trying to develop a minimum viable product regarding data spaces, but with a test bed that we have in the university. Another topic that is very interesting is a new proposal for integrating to data spaces is how we can match ODRL with Zero Trust and RBAC, that is a relationship-based access control that could be included inside of data spaces. So we are going to show some examples of how this solution fits very well with this scenario. Okay, if we start with the first topic, we are going to talk about protocols. As you know, this is a very simplified view about data spaces. All is about connectors and how these two things can share data. And we have many actors in this case. This is a very simplified view because we only want to show you all of the things that we need to consider only in the terms of transfer different data in this case. Only in the transport for these two connectors, we have to consider these four things that you can see in the slide. We have the identity, we have the transfer of different implementations, contract negotiation, and also the metadata description that we need to consider for the data sharing in this case. And we are going to focus in this part that is in the yellow circle, that is how we can transfer data using different protocols. Because as you know, you don't have only way to transfer the data once you want to share data between two or more participants. So in this case, we are going to propose something that is very similar to the SIP protocol, SIP protocol from the telecommunication part. This SIP protocol is a protocol of voice over IP, in where we have some first part that is a negotiation. We have to send some signal and have an agreement, and then we use another protocol to transfer, in the case of SIP, transfers the voice and the multimedia. In this case, we have the first part that is the agreement with the other party to define how we can share this data and then use another protocol to share this data. Depending on the situation, if you have, in this case, two scenarios. You have batch data and also streaming data. For batch data, it's easy because you can perform some ETL operations using the query and request operations. But for streaming data, you need to capture this data and having in near real time. So you have different approaches to use the different data. However, these two forms of get the data are not the only requirement for data sharing in this case. So in this case, we are proposing, if we have different protocols, to using different connectors, in order to share this data, you have in one way or another to define how you can or how you want to share this data. And we propose more an idea that is a protocol wrapper, okay? And how we will implement this? We're using the power of ODRL. We're using ODRL to define the protocol, put the definition in ODRL, and then storage this information about the transfer inside of the PIP that in a similar way of the access control. So this is a very good approach because we have the same infrastructure, the same way of working that we have in access control. And also when we are going to see more in in more detail in some slides after, we are using the zero trust architecture. That is another thing that we are proposing. So when we define this ODRL, we can add this to the different profiles of ODRL. In this case, our university, our group, is right now working with the W3C for providing this semantic and vocabulary regarding not only the protocol, but also some things regarding to access control and data usage control. That is another topic that we need to cover in this ecosystem. Okay, suppose that we are in a point in where we have all configured to start to share data. We have defined the protocol, we have defined how we can share the data, we have the first part that is the identity and all of this part, but we want to share data with another participant. We also need to consider how is this data that we have in the source and how we can capture in this case, in the sync or in the destiny. So in this case, depending on the data, if it is small, it's very easy to work with that part. But if we have a very big data set, we need to treat this data in another way. So our proposal in this part is also trying to define or use another set of protocols for sharing this data. In this case, we are using the quick protocol that right now is has in a version 2. The quick protocol is an evolution or a replacement of HTTP. We use the same way of transfer, but removing all of the additional handshake that we have in HTTP, reducing this latency and have more speed in the transfer of this information as we previously do in HTTP. So as we have a very big data set, we need to store this data in an efficient way for being transferred. So what is the proposal in this part? Use some of the open source, in this case, format for storing this data. In this case, we are using Apache Parquet. That is another solution that allows us to put this data in some format that is very easy to transport to another point and also very efficient utilizing another protocol like Quick. So we mix these two things and we rely all of these things in the processing engines that are in the big data ecosystem. So we are optimizing all of these pieces for transfer these two things using all of the previous steps that we need to in this ecosystem, the part of identity, the part of negotiation, the part of definition in ODRL about the protocols that we are going to use, and also providing the power of the big data engines for transfer this data from one side to another. In this part, we have a little problem because when we are talking about the engines of big data and many other pieces like Parquet and also DRL, we need some way of orchestration. We need to provide this to the users in a transparent way. We don't want that some user have to think about, I have to deploy a cluster of Spark. I have to deploy a cluster of Kafka to read this information. So our approach is to provide this in some way similar to MLOps. We provide a complete pipeline to use that the user only have to perform 2 or 3 tasks and have the ability to use this type of technology. So in this case, we're trying to integrate all of this MLOps part inside of the FireWire data space connector. Because we have a lot of background in fireware because we have been working with fireware for many years and also developed some of the components that right now are using in fireware, like the identity manager, that is Keyrock, the historical data, that is Draco, and also the big data, that is Cosmos. So it's very easy to us to work in this part because we are the main contributors to these components, and also it's very easy to integrate these proposals in this ecosystem. Okay, and now is the turn to Carlos.
No, I have my own microphone. Hi, everybody. How are you doing? So this time, for me, it's time to present a little bit a couple of points which we think are interesting, mainly in the researching line we are following along. And the first thing I want to talk to you is how to get the trust framework goes intergalactical. And I say intergalactical because when we speak about interplanetary, all the people point to the interplanetary file system. So I didn't want to have like a confusion there. And okay, I think everyone is like more or less familiar with this kind of a schema, which is the schema of the self-sovereign identity. Gaia-X is working very hardly, very hard in this kind of concepts. And okay, so the SSI architecture, the stuff we used to have, or the stakeholders, is like an insert, a holder, verifier, and we need a verifiable data registry. How does Gaia-X address all this stuff? Okay, everyone, I think, is very aware of this schema here. Otherwise, I don't know what are you doing here. That's a joke. And okay, in case of Gaia-X Trust Framework, it's addressing like this kind of SSI or self-sovereignty identity to the ecosystem of Gaia-X. What's the thing about Gaia-X and why do we think that's very interesting? Gaia-X is like trying to address the problem of cross-border systems, but that is kind of very easy here in Europe because we have already the ecosystem of ETAS or ecosystem of ETSIT, which is based in the rules of the European Union, and that's pretty cool. But we have a brand new requirement, was born like a couple of months ago, and we were talking about not only deploying stuff here in the European Union, but also in China, also in NAFTA, also in Japan. So what's the problem? Maybe stakeholders of China, Japan, and so on, they don't want to relate to the ecosystem which we have here in Europe. So if they want to make business here in Europe, of course they have to fall to the European regulations, which is normal, but maybe not to the European infrastructure. Data does not flow in rainbows, like they say the other day, Pierre, right? So how to address this brand new requirement? So we have new requirements, of course, technical requirements. First of all, we have to be able to connect multiple trust anchors depending on the use case sector and also global location. These connectors have to be interoperable with each other and manage similar standards. And in this way, we can address, of course, requirements of ID binding, proof of participation, and proof of authority, which is very important, like this said in the technical convergence document, and in a global scale, not only in a European scale. So we are having like different lines of working. First line would be the W3C solid inspiration. The other day we were like presenting here, we were present here in a very interesting presentation of our colleagues from France speaking about solid. We think solid could be a very well way in order to address this thing. So we are researching on it, but we are not sure enough right now, but we will provide some information extra maybe further. And for example, another idea would be like interoperability exchanges messages in a standardized way, because right now, so like the messages we have are standard, but are standard in a silo of standardization. So for example, like trying to get to standardization like in the MIMI ETF, which is a protocol to address the problem of interoperability between messaging, could be also a very interesting point. So it's very important also to provide a test network, and we are like relying mostly in blockchain and DLTs. DLTs like Hyperledger, Indy, Aries, and Credo. So we're right now like developing some kind of demonstrators and some kind of like minimum viable products in order to prove that we are able to switch between different trust anchors, and these trust anchors are going to be, in our development, mainly based in the Hyperledger Indy and Fabric, but we wanted also to do it compatible with the clearinghouse. For us, it would be very, very nice also to deploy like a test network in order to be able to iterate more quickly in the different application pieces of software architecture that we have to develop in order to get the data spaces done. And okay, that's enough about like going intergalactical. And we want to share with you also some lines we are developing about governance aspects, such as we were talking before about the ODRL profile. You know, you're aware of it, but what's going to be with the data usage control implementation ideas, and like we are like working already in these lines. In fact, Andres, Joaquin, and Alejandro were presenting in the Tech Bilbao 2023 an ongoing work, and we are working further on it. We hope maybe in November in the summit in Helsinki we will be able to present you something further and with face. So like we say in Spain, with face and eyes, to touch, to be touched, and to being able to interact with, especially for the stakeholders which are not necessarily technical, more business or whatever, like with a good UI and so on. And for example, we are working mainly in ODRL. A couple of things we are working on very hard is in how to get the data access control and evolving this data access control to reback. The other day, Pierre was mentioning reback, and reback is like a buzzword right now in the data access world, like a buzzword more or less, because also we all are like kind of used to listen to words like ABAC, airbag, but not reback. Sorry with those terms, but are the way they are. And with the agenda of Google Zanzibar and AWS Cedar, so we are aligning ourselves more or less in this line of describing policies. This reback is not only like saying, okay, so you have an attribute as a user, and based on your attribute, I'm going to allow you to get into my ecosystem or to my service, but it's more based in a relationship graph. Everyone could say relationship graph, what's that? But it's something we are using the whole day, because, for example, if you get to the Google Drive and I share, for example, with you a document, this document, for example, if this document is in a folder and I share with you the folder, so you will be able to see the document because the access control is not in the document as such, but in the folder. So what we are doing, what we are seeing there is a relationship, is a graph. So it's very, very interesting for us, very inspiring, because it's another way to see or to consider the policy access and the usage access.
The key point here is that you are using this type of approach right now. Every day when you are using Google Drive. So we are using this approach because it's something that is using right now, also in complex systems like GitHub and many other things. So it's a very good approach to put here and trying to evolve the ecosystem.
Thank you very much, Andres. He was like more concise than I was. And okay, so right now we are trying to map this system of reback with OpenFGA. OpenFGA is a very interesting project. I'm going to go a little bit further because we are like kind of out of time. But so we are trying to get this project, OpenFGA, which was presented in the KubeCon. So we were all together in the KubeCon in Paris like a month ago, and it was a team like presenting this OpenFGA, which is a very good implementation and very, very advanced and developed implementation of the reback system. And so we are like going with that. So we were also experimenting a little bit with Open Policy Agent, with OPA. Yesterday, OPA was mentioned several times, but I think that's the first time here in this conference which OpenFGA is going to be mentioned, and I think it's worth. And the configuration language that we see here is like a way to propose a model, which is a relational model, against which we can throw the petitions of the requests of the access control. After. So with this configuration language, for example, in this case, we can see like user can be a member of a domain. So this is expressed in this way. And for example, how could be mapped ODRL policy to reback? For example, here we have a very good example. That's ODRL with the context, with type, UID, permission, target action. Then in this case, you can see, for example, how does it map to the reback. And for example, here in this case, another case. And for example, here is when we find like the most important case in which we are working right now, because that involves also like algebra, and we are working very hard on it. In fact, that's going to be our main line of implementation in the future months for our group, which is how to get the ODRL policy and all the algebra which is involved, and trying to map it to the reback system and with OpenFGA, because also with OpenFGA and with the Zero Trust, which I didn't talk that much about because we were like kind of short of time, it is possible to. Here it is possible to deploy in a very huge scale the different policies, not only to one connector, but maybe to thousands of connectors in the same time. I'm having observability monitoring of all this data access control, and it's very easy to evolve the data policies and after deploy them in a very huge scale. So that's more or less the line we are following right now about ODRL and OpenFGA. And okay, some future work. I give the word to my colleague here, Andres.
Thank you.
Thank you very much.
One or two things that I want to remark about all the presentation with Carlos. For example, if you have in mind that you want to map ODRL with OpenFGA, you think that you have to map one graph to another. So it's very easy, because ODRL is expressed in form of graph, and you have OpenFGA that is a graph itself. So it's very easy, the translation. We are working right now in the middle of these two things, providing in this case, the translation engine. Took this graph, writing in ODRL, and translate it using process algebra to, this case, the definition of OpenFGA to apply these policies to the things that we want to apply. Okay? And that is the way that we are trying to face in this research problem in some way. Okay, and talking about the future work, we are open to collaborate. We are working in this project. This is a 3-year project. We are right now making the interesting part that is developing. The first part was researching, reading. Carlos was reading for months and months and months, trying to have all the Gaia-X power in his mind. So right now, he is the person that has all the picture, and we are trying to coordinate and put all of these ideas inside of this ecosystem. So we are open to collaborate. We are working in many standardization platforms. We are open to discuss and introducing new things. And we are trying and put a lot of effort from our university to define a testbed for being used for many things that want to play with these data spaces, the part of onboarding, the part of generated SI, and many other these things that we consider that is really needed to start in the world of data spaces and pass to the intergalactical data spaces. Thank you.
If you have any questions, remarks, and you can, I don't know, like insult us or whatever. No, just joking. So we're here available for you. And if you don't want right now, because we are so many, maybe it's a little bit awkward. So we're going to be around here to talk, chat, whatever, exchange emails, having a coffee together.
Thank you so much.
Thank you so much for your time. Bye-bye.